Hello everyone, in this video we are going to learn about the regression plots in Seaborn library, and following are the topics that we are going to discuss. Firstly, we will see an introduction about the regression plot, then we will learn how we draw the regression plots. After that we will discuss regplot function and lmplot function. So let's begin with the introduction to the regression plot. So regression is a statistical technique used in the field of disciplines that aim to determine the strength of the relationship between a dependent variable and few independent variables. So when we conducting an exploratory data analysis, the regression plot in Seaborn are primarily designed to provide a visual aid that highlight the pattern in the dataset. As the name implies, the regression plots provide a regression line between two parameters and assist in visualizing their relationship. Basically, the linear regression determines the linear relationship between two variables based on the line of a best fit, or you can say that a best fit line. And you know that the best fit line is graphically depicted using the slope of a straight line, defining how changing one variable affect the change of another. So now we will discuss how we draw a regression plot in Seaborn library. So if you want to draw the regression plots in Seaborn, we have two functions. The first one is regplot function and the next one is lmplot function. So we will discuss about both of the function in details one by one with the help of example. But before proceeding to the function, note one thing: both of the function do not support regression against the date data. So it is not possible to plot a time and date plot using these two functions. So now we will discuss about the regplot function. So firstly I explain you. The regplot function is utilized for displaying a linear relationship as established by regression. Or in simple words, you can say that the function plots a scatter plot of the two variables x and y, and it fits a regression model. And the plot show the regression line and a 95% confidence interval for that regression. And the syntax for this regplot function is as follow. So you have to write Seaborn regplot, and in parentheses you have to pass the different parameters. So I will explain you the parameters which are used. So first two are x and y. These are the data points that define the x and y axis location. The next one is ci. It is the size of regression estimate confidence interval, and the translucent band around the regression line will be used to depict this, and by default it has a value 95, and you can even set it to none if you don't want to see the translucent band around the regression line. The next one is color. So to apply the color to all the plot element, we have to pass the color as a keyword argument to this function. The next one is marker. It specifies the style of the marker. By default it is a circle. You can change according to your choice. And the last one is data. It is the data set that is being used. And to learn about this function in detail, we will see examples. So here is the example. I will explain you line by line. So firstly we have to import the necessary library, as you know that it is the most important step. So I import the Seaborn library, as we are working on the Seaborn library, and I import it as Seaborn as SNS. SNS is an alias name for it. Then I import the matplotlib pyplot library. As the Seaborn library works on the matplotlib library, so I import this library as a PLT alias name. Then I want to read the dataset which is by default mentioned in the Seaborn library. For this reason, I call the function load underscore dataset of the Seaborn library and pass the name of the dataset as an argument. And the name of the dataset is here is a taxi, and I assign data underscore set variable to it. Then I want to print that top 5 dataset values. For this reason, I call the head function and use the print function for printing it. So now I execute this cell and show you the output, how the dataset looks. So you can see that this dataset gives information about the passengers who have traveled in a taxi, and it also shows that whether they give the tip to the driver or not, their pickup and the drop off date and time, number of passengers, distance traveled, fare, toll, total, pickup and drop off zone, and pickup and drop off route also. And it also talk about the payment method like a credit card and a cash, or the taxi's color which is used by the passenger as a yellow and a green. So now we will see an example using a regplot function. So firstly I call the set function as I want to change the appearance of the plot, and here I pass a style as a keyword argument to it, and I set its style to the dark red. After that I want to visualize the relationship between the total and the fare data points of the taxis dataset as a reg plot. So I call the reg plot function and set its x value to the total and y value to the fare. This total and fare is the name of the column which it picks from the dataset. Then I want to add a labels at the x-axis and the y-axis. So I call the x label and the y label function, pass label as an argument to it, to both of the function. Then I also want to change the font size and the color of the labels. For this reason I pass a keyword argument font size, set its value to 15, and also pass a color argument and set its value to dark red. Then I want to add a title on the plot, so we get to know what this plot represents. I call a title function, and to modify its appearance I also pass a font weight keyword argument and set its value to bold. And next I call the show function as I want to show the plot. Now I execute this code and I will show you the output, how the plots look. So here you can see that the x-axis represent the total, y-axis represent the fare, and this plot represent the total versus fare. And you can see that here we have a scatter points in the form of a dot, and in center of these we have a line. This line is known as a best fit line. So now we will move ahead and see one more example. So this time I again call the set function as I want to change the appearance. Then I pass a style as a keyword argument, but this time I set the style to the white. Then I call the regplot function as I want to visualize the relationship between the distance and the fare of the taxis dataset. And addition to this, I pass a keyword argument color to apply one color to all elements of the plot. And then I call a x label and the y label function to adding a label, title function to add a title, and the show function to show the plot. Now I execute this cell and show you the output. So here you can see that we have a plot in which the x-axis represent the distance, y-axis represent the fare, and this whole plot represent the distance versus fare. And you can see that it has a scatter points and a one regression line or a best fit line. In the color which I mentioned above, so I mentioned a deep pink, so it shows a line and the scatter points in the pink color, but by default you can see that it shows the line and the points in the blue color. And note one more thing here, as I mentioned a dark red color for the x label and the y label, it is represented in the dark red color. Now we will see one more example. So here I call the set function as I want to change the appearance of the plot. I pass style as a keyword argument, and this time I set its value to dark. Then I call the regplot function as I want to visualize the relationship between the distance and the toll of the taxis dataset. And addition to this, I pass a one more keyword argument. You can see that this is a marker, as I want to change the marker style of the element of the plot, and I set its value to small d, which represent a diamond. Then I call the x label and the y label function to add a labels, title function to add a title, and the show function to display the plot. Now I execute this cell again and show you the output. So here you can see that here the y-axis represent the toll, x-axis represent the distance, and this whole plot represents the distance versus toll. And here we have a regression line. You can see that here we have a translucent band with the small width, but it is visible lightly. And you can notice one more thing, as I have passed the marker keyword argument and set it to D. Now these marker points or the scatter points are represented as in the shape of a diamond instead of the circle. Now we will move ahead and see one more example, and this time I call the set function again, pass a style as a keyword argument and set its value to dark. Now I call the regplot function as I want to visualize the distance and the total relationship of the data set. And here I pass ci equals to none. Ci is a keyword argument which I pass and I set its value to none, and the reason behind that, I want to remove the translucent band around the regression line. Next I call the x label and the y label function as I want to add label. Then I call the title function as I want to add title, and after that I call a show function as I want to display this plot. Now I execute this code and show you the output. Now you can see that this regression line is shown without any translucent band. So in the above case we have a translucent band around the regression line or a best fit line. I will show you by maximizing its size. I think it is not visible. So now it is visible. You can see that we have a translucent blue color of the band around this regression line, which is removed in the case of the second example, in which I pass a keyword argument ci and set its value to none. We can also change its value. By default it has a 95 value, so if I set it to 180, see what will happen. Now I execute this code. So here you can see that it shows an error. This error is shown because it gives a message the range lies between 0 to 100. As I have passed 180, so it will shows an error. So you have to change it. So I set it to 100 now and execute it. Now see how it's look. So you can see that now these bands look wider as compared to the above example. So with this we have learned about the regplot function. Now we will learn about the lmplot function. So firstly I explain you what is lmplot. So it is another way to create a regression plots in a Seaborn library, and the lmplot function is used to create a linear model plot. It creates a scatter plot with a linear line on top of it. Basically the regplot function is the subset of the lmplot function. So you can say that regplot only has a portion of the functionalities of the lmplot. So by using lmplot we do more functionalities in a regression line. And the syntax of this lmplot is seaborn.lm, and in parentheses we pass different parameters. The parameters are as x and y, the data points that define x and y axis location. The next one is hue. It is a grouping variable that will produce component with different colors. The next one is row and the column. It is the variable that specify the subset of a different plotting facets. The next one is ci. It is the size of a regression estimate, confidence interval, and it is a translucent band around the regression line that will be used to depict it. And the next one is palette. To apply the color to all the plot elements we use this keyword argument. The next one is aspect. Each facet aspect ratio determines its width in inches, which is calculated as aspect into height. The next one is scatter underscore KWS. It is used for passing additional keyword argument to the plot.scatter function. The next one is marker. It is used to specify the style of the marker. Then we have a height. It is the height of each facet in inches. And the last one is data. It is the data set that is being used. So now we will see different example related to the lmplot function, so we clearly understand this concept. So Here you can see that firstly I call the set function to set the appearance of the plot, and then I pass a style as a keyword argument to it, and I set its style to text. After that I call the lmplot function, and this time I visualize the data between total and the fair data points of a text data set. Next you can see that I call the x label and the y label function, pass label as an argument to the both of the function. Additionally, I set its font size to 15 and color to royal blue. Then I call the title function as I want to add a title on the plot, so we get to know what this plot represents. And to beautify it more, I also change its font weight to bold. And last I call the show function to display the plot. Now I execute this cell and show you the output. So here you can see that we have a total versus fair plot in which the x-axis represented the total, y-axis represent the fair, and here is the scatter plot with the regression line, or you can say that a best fit line also, or it is also called as a linear line. So I will show you a difference between a regplot function and lmplot function. So here you can see that when we call the lmplot function, the plots look something like that. Now I will show you the output for the regplot function in the same case. So here is the output of the regplot function for the total versus fair. You can see that this plot is wider in the width but lesser in the height as compared to the LM plot. I will show you the LM plot again. So here is the LM plot. You can see that it is wider in the height. So now we will see one more example. This time I call the set function, pass style as a keyword argument and set its style to the white grid. After that I call the LM plot function to visualize the data between distance and passenger of the Texas data set. Additionally, I pass a Q keyword argument to group the payment data points with different colors. And here I call X label and the Y label function, title function and the show function. You know that what these function does. So I execute this cell and show you the output. So here you can see that the x-axis represent the distance, y-axis represent the passengers, and here we have a two color of a scatter points and also the two color of the lines. So the blue color represent the credit card as a payment method and the red color represent the cash as a payment method. So you can also observe that we have a translucent band around both of the line which represent the confidence interval. So let's see one more example. This time I set the appearance of the plot to white and then I call the lmplot function as I want to visualize the data between total and the tip data point of the Texas data set. Additionally, I pass a hue keyword argument to group the passengers data point with different colors, and I also pass row and the column as a keyword argument to define the subset of the plots on different facets such as payment and color respectively. And here I also pass a palette as a keyword argument and I set its value to set 2 because it generates the scatter plot with different color map values. Then I call the show function and now I execute this cell and show you the output. So here is the output. I will show you. So you can see that here the column represent the colors. Like the first column represent the yellow color and the second column represent the green color, and rows represent the payment method. The first row represent the credit card as a payment method and the second row represent the payment method as a cash. And here the different color of a scatter marker are based on the passengers, and here the x-axis of these plot represent the total and the y-axis of each plot represent the tip. Now we will move to the next example. This time we call the set function and set its style to the dark. Then I call the lmplot function as I want to visualize the data between distance and the tip. And additionally, I pass a hue as a keyword argument to group color data points with different color. And I also pass a aspect and a height as a keyword argument to set each facet aspect ratio, which is calculated as a aspect into height and height of each facet in inches respectively. And I set the aspect ratio to 0.8 and the height to 9 inches. Then I call the X label and the Y label function, and then I call the title function, and last I call the show function. Now I execute this cell and show you the output. As I set the height of the plot to 9, you can see that this plots look too longer. This plot represents the distance versus tip. X-axis represent the distance, Y-axis represent the tip. And here we have a two color of a scatter marker and regressions line. The first one is blue color. It represents the yellow color taxi, and the red scatter and the line represent the green color of a taxi. And its aspect ratio is set to the 0.8. Now we will see one more example, and this time I set the appearance of the plot to the dark grid, and next I call the lmplot function as I want to visualize the data between total and the tolls. Additionally, I pass a hue as a keyword argument to group color data points with different color, and I also pass a scatter underscore kws parameter that changes the size of only the scatter points, not the regression line. So I create a dictionary in which I set the key as a small s, which represent the size, and I set its value to 100. This only change the size of the scatter marker as it is work as a function of a pie plot scatter. Then we set the markers to have a categorical distinction in our plot that originate from the plotlib marker symbol. So as we have a hue argument which is based on the color, we have to set the markers of a two type. For this reason, I create a list, pass two types of marker to it. The first one is circle and the second one is arrow sign. It will help to distinguish between two categories. And I also set the CI keyword argument to none as I want to visualize the linear model plot without any CI band. So next I call the X label and the Y label function, title function and the show function. Now I execute this cell and show you the output, how the plots look. So here you can see that first of all, these two regression lines or linear models line don't have any translucent band around it. So it means it doesn't have any confidence interval as we set the CI to none. Next, this plot represents the total versus toll, where x-axis represent the total and the y-axis represent the tolls. Then we have two different types of markers. The circle in the blue color represent the yellow color taxi, and the arrow with the red color represent the green color of a text. And I hope you have noticed that in the previous cases the size of a scatter marker are small, but in this case as we have the change the size of the marker to 100, it looks bigger. So with this we have learned about the regression plots, and in the next video we will learn about the matrix plots.